Welcome to Hartman Math. This is lesson 6.5 Logarithms. So example number 1, we want to find the inverse of this exponential function. And we know the steps to finding the inverse. Step number 1, rewrite it as y equals. Step number 2, switch the x and the y. Now we solve for y. So we've never had it where we've had to solve where our variable that we're solving for is the exponent. So we're going to look at how that's done. What's going to happen is we're going to rewrite this from an exponential equation into a logarithmic equation. So essentially what we do is we pull down the y so it's just at normal level, and that displaces the 2. So we pull down the y, the 2 gets pushed out of the way, so it's going to go over to the other side. And over here, 2 is the base of the exponent. When we rewrite it into logarithmic form, it becomes the base of the logarithm. And algebraically, we abbreviate logarithm as log. So it becomes log base 2. So look, it's written small and low as a subscript, base 2 of x. And that is the way that we say this. Log base 2 of x. You say the word base, you say the number, then you say of x. And we know that our last step is to rewrite this as f inverse of x is equal to log base 2 of x. The base of the exponent is the base of the log. So we had a base of the exponent here is 2. When we rewrote it, that's the base of the logarithm. And that idea of rewriting from one form to the other is really important, not only for the finding the inverse form, but other things that we're going to do. So let's get some more practice. Example 2, this is an exponential equation. Let's rewrite it as a log equation. So we're going to move the base. That's the secret. Move the base. 6 is the base. So we're going to move that to the other side. That's going to leave 3 by itself. It drops down. It comes a little bit larger. 3 equals. This is exponential. We're going to rewrite it into log form. Log base 6 of 2/16. So we move the base, and now it's the base of the logarithm. Now you try, pause it here until you've rewritten it into log form. All right, once again, we're going to move the base. The base is 4, so it's going to move over here. Negative 2 equals log base 4 of. And sometimes you might see the 1/16 written in parentheses just for clarification purposes. Make sure we write the 4 as a subscript, little and low. Example number 3, we can reverse that process. We've got a logarithmic equation here. Let's rewrite it into exponential form. Same secret, move the base. Base is 7. It's going to move to the other side. So since it's no longer going to be a log equation, don't need the word log anymore. 49 will stay over here. And then 7 is the base. And then that means it bumps up the 2 to be an exponent. And I think that makes sense, right? 49 equals 7 squared. Go ahead and pause the video here while you rewrite this log equation into exponential form. All right, we're going to move the base. The base is 9, so 3 equals 9 to the power of 1/2. Make sure that your 1/2 appears to be an exponent. It needs to be high. So do not write it, because I keep seeing this as this, 9. That does not look like an exponent. I read this as 9 1/2. And we don't ever do mixed numbers, hardly ever. I need to see it as 9 to the power of 1/2. Example number 4, evaluating logarithms. So a logarithm, kind of the phrase here, log is an exponent. That is our password. A log is an exponent. So some of these are going to be reasonably obvious where we don't need to show any work. What it's saying is, in this problem, 3 is the base. We're looking for the exponent. 3 to what power is 81? What exponent goes here to make this a true statement? Answer that would go there is 4, so 4 is the answer. Don't write it like this. The answer to the problem is 4. 3 to the 4th power is 81. So the answer is 4. It's the unknown missing exponent. Go ahead and try this one. This one's a little tricky. So we read it as 5 to what power is 1/5? 5 to what power is 1 over 5? Well, that would have to be the negative exponent property to flip it like that. And we're talking about a log as an exponent. So to flip it, the answer is just -1. That's what flipped it. That's what we learned back in Unit 5. So it's -1. Example 4, Part B. Log base 9 of 27 we're supposed to evaluate. So the question is 9 to what power is 27? The answer is not 3. It's not 9 times 3. It's 9 to what power? 9 to the 3rd power means 9 times 9 times 9, and that's much bigger than 27. So this probably isn't one that we know off the top of our head. So we're going to need to figure out another way to do this. So here are the steps when we don't necessarily know. And if you had trouble on the last U try, this technique might help. Turn it into an equation. Make it equal to something. Step 1, set it equal to some variable you choose, whatever you want it to be. Say we say H. You could pick K, you could pick X, you could pick R. It doesn't matter. Second step, rewrite it like we were doing before, from a log equation into an exponential equation. So rewrite from one form to the other. Move the base. 9 is the base, moves over here. So we get 27 equals 9 to the power of H. Next step. For both sides, we need to choose a common base. So what we're saying is 27 and 9 are both powers of what number? Think about it. 27 and 9 are both powers of what? The best answer that we can come up with is 3. So we want to rewrite them with exponents. So we're going to rewrite this as 3 to the 3rd power. 3 cubed equals. And then over here, 9 is 3 squared. And then that's going to get raised to the power of h. But earlier we had learned when we're raising a power to a power, we just multiply the exponents. So it becomes 3 squared to the h means 3 to the 2h. So once you have both sides written as powers of the same base, we equate the exponents. The only way that this can be true, because they have the same bases, is if we ignore the bases, we say exponent equals exponent. 3 equals 2h. Now solve for h. When you get done, box not the equation, not the h because we made that part up, just the number. So if we divide both sides by 2, we get 3 over 2. Only box that. Don't box the h. We made up the h. You might have done k. You might have done r or m. Doesn't matter. The answer is the number that's kind of the missing exponent. Example 4, part C. Ooh, this one looks tricky. So let's talk about it. Part C, let's go through those same steps. Step 1, set it equal to some variable. You pick the variable. Now we're going to rewrite it. But on this one, when we do rewrite it, the decimal is not our friend. So we want to turn that into a fraction. So we can think of a couple ways to turn that into a fraction. Okay, 0.25 means 25 hundredths. So you can think of it as 25 over 100 and reduce. Or you can think of it in terms of, hey, that's like a quarter. That's like 25 cents is a quarter. A quarter is 1/4 of a dollar. That means 1/4. So as we go to rewrite it, let's keep in mind that we want to turn that into a fraction. To rewrite it, move the base. So the 2 moves over. 1/4 equals 2 to the power of h. All right, now let's think of both sides are powers of what base? And when we choose a base, you really don't want to choose a fraction. So choose a whole number as your best plan. All right, so they're both powers of what base? I think our best option is 2. So we don't need to mess with this, we just need to rewrite this. For example, rewrite the left as 1 over. Now 4 is 2 to what power? Let's write it like that. 1 over 2 squared. Now let's flip it up, and to level change it, we have to change the sign of the exponent. So 1 over 2 squared is the same thing as 2 to the negative second power. We've kind of done this in reverse before, but now we're doing it this way, is equal to 2 to the h. So we've got both sides to be powers of the same base. Now equate the exponents. H equals negative 2, just box the negative 2, and that's our answer. Go ahead and pause the video while you work on the U-try. See if you got it right. Equal to W. Pick whatever letter. Doesn't matter. Let's rewrite it. Move the base. 2 equals 8. Bumps up to the power of W. All right, let's rewrite both sides as powers of the same base. So 2 and 8 are both powers of. And our best option is 2. So 2 to the third. Raised to the W means times W. Over here, this is 2, and we could probably write it as 2 to the first. That might help out with our next step. All right, so now we can ignore the base. We can say 1 equals 3W. Divide both sides by 3. There's our answer, 1/3. Let's kind of check that, see if it makes any sense. 8 to the power of 1/3. Remember that means, since the exponent's a fraction, rewrite it as a root. Q root of 8 is 2. Check. And that's it for today. I'll see you next time.